All right. Let's get this going, hopefully. Even though the windows are a little weird. Does that still work? No, I must have messed something up. Oh no. Well, hello. I might need to fix the windows here for a second. This guy is broken, right? Oh, this one shouldn't be shown. Ah, now it's all good. All right. Hallo Maschinengewalt. That name would have fit much better when I was playing Satisfactory. All right, cool. So here we are now. So it's been a while, but let's do some more WebAssembly. Please let me know if the font is large enough. I can make it a little bigger. Yeah, that's probably better. Let's go with that for now. So, last time around, we put together, and again, that's been a while. That was some time ago. We put together our own little WebAssembly module in our AST, and managed to make the generated WebAssembly perform some calculations for us. Well, it did this for us, but there's a lot of stuff here that is kind of not so great. We need to manage our indices by hand. So this type 0, we need to make sure we actually put that type in here, and that's not what you want to do when you're actually writing a codegen backend for a compiler. You want ideally to have these indices handled for you by some level of DSL in between you and the raw representation. There's also a bit of a problem here where we're going to be running into when we do recursive stuff, because function referencing itself, it's kind of tricky because you need to know your index before you are defined, in a sense, which is a bit hard. And yeah, so ideally I'd like us to have our own little DSL, and I started building that on my own just to get a feel for what that would look like. I think I have a plan for how we're going to go about it, and I'd like to do that on this stream. So the idea is that eventually we should be able to write this code generator in a nicer way, essentially. Yeah, so that's the plan. So let's go into Wasm, and I'm going to call the module, let's just call it maybe builder or something. So the idea is that this is a module builder, really. So maybe we should call it that. And what you'll find is that we're going to use a fair amount of unsafe stuff under the hood to make this go, but that's fine. So my plan for the builder, what I want to have is a builder type that is monadic, that gives us our DSL. And so I have on the right over here, and you can see that this is all of the stuff that goes into a WebAssembly module. Maybe I can increase the size of that a bit as well, though that cuts off stuff on the side. I'll just leave it like so. So this is what makes a WebAssembly module, and we want to build this sort of incrementally in some monadic syntax that does a bunch of bookkeeping in the back. So what we want to have essentially, so what's the stuff we want to do? We want to be able to define functions. By giving the type and their export name, maybe. I'll just say define functions for now, and we'll go into details on why that's hard or what kind of tricky stuff we need to do. What we also want to be able to say is we want to define the exports, and eventually we probably want to actually define which functions to export. So maybe that actually goes into define functions. What do we want to be able to do? We want to declare memories that we're going to be using. We might want to export and import these as well. I'm not sure about that yet. We can figure that out. What else? And I'm not going to label these. Let's just go with dashes for now. What else do we want to be able to do? We want to be able to define functions. We need to define globals. And that also includes their initialization logic. Let's actually put that up there. That seems a little more important than being able to declare memories. And let's say we want to be able to declare the start symbol. And we might fold that into defined functions, or it might be because there's only a single function that is the start symbol, we might want to do this as an extra thing so it doesn't pollute our function defining declaration thing. We want to declare tables and their element sections, and ideally we want these things to be, well, maybe we can make a thing that lets us do this in one go rather than having a bunch of instructions that accumulate them. And then we want to somehow also be able to declare data sections. And I have no clue how these work yet. That's where you put your static text and stuff. We'll figure that one out maybe once we actually get to using this. With the memory declarations or something. But I'm not sure about that one yet. So the thing we definitely need is globals and functions. And we will also need to be able to define tables. What are tables? What do they do? That's a good question. So let's look into that so that we can make sure that we're all on the same page. So this is the WebAssembly reference again. So the tables component of a module defines a vector. Okay, so let's skip that part. It's kind of abstract, this part. So a table is just another piece of data in your WebAssembly module. It maps functions to names. Wait, it maps. How do I talk about this? So the only way you can use tables right now is to have a thing where you can put function references. So basically, WebAssembly doesn't have function pointers. Instead, it has indices into a table that contains a bunch of function references. And so if you want to do indirect calls, you need to use a function that is stored in a table. That is a limitation that is right now, though. So that will change. You can use tables to store all kinds of more intricate stuff in the spec already, but the implementation is not there yet. So, all right, great. Thanks for the question. That was a good question. And again, maybe we might want to say, well, maybe we just want to say declare that a function appears in a table and not have this as its own thing. But we can always fold more thing into the defining functions thing. We'll just have them as their own for now. Okay, so now let's define our builder. And again, as I said, I wanted this to be I want our builder to be a monadic thing. So it's going to have a type variable, and it's going to be a reader t. So we'll have some kind of environment over effect an a, like so, and we're going to import from reader, and this env is just an empty record for now. Okay, like so. And now one thing you can do in PureScript, and it's kind of annoying because it's so long, but so we're going to do a new type deriving here. So I think it's new type, derive new type, like so. And we'll start by defining functor for builder. So sorry, functor builder. Is that not how that works? New type derive? No. Is that not how it works? First need to derive an instance of new type. No, that's another thing. No, wait, let me show you. There's a whole bunch of levels of new type deriving in PureScript, and I wish we could make them a little less confusing. So let's find the instance declarations. Is that here? Is that not here? Language. Type classes. Maybe we can find stuff over here. So that's instance chains, orphan instances, type class deriving. So this is the bit. So we can derive instances like this. Oh, so what I need to do is derive new type instance, I believe. That's the invocation. But I'll happily talk about what's going on here. So this is the bit we need. So this is not deriving the new type class, right? The new type class lets you wrap and unwrap this thing. And I don't want to do this because that would let outsiders peek into the representation of builder, because the builder has a bunch of references inside. So we're going to put it into effect. But from the outside, I actually want this interface to be pure. And so one thing I may not do is deriving the new type class, because that would let outsiders just unwrap the class and get at its inside. But what this thing does is it tells the compiler to basically just use the instance of this thing interchangeably. Well, someone always assumed that you first need an instance for new type in order to say derive new type instance. Yeah, I can see why you'd think that, but because we defined this instance right next to this data type, we don't need the ability to unwrap it, right? Because the compiler can look at both of these at the same time. So that's why that's not necessary here. And now we're going to derive a whole bunch of others here. So the PureScript hierarchy here is a little... That's good. It's always a good thing to delete more code. So let's go and we'll derive a couple more of these. Apply applicative, I believe. So this is apply, actually, like so. And then we're going to derive bind. So getting up to monad in PureScript is a little convoluted, and I wish it wasn't. We have a bunch of classes in between. So this is, all of this is just so we can use do syntax for builder, really. So let's not look at that too long because that's horrible, but at the same time it's good to have it. It's a lot nicer than having to write this by hand. Okay, so what are we going to do? One thing I want right away is I want to start figuring out what kind of stuff we want in the env and kind of the public interface we want to have. So one thing we'll want to do is we'll want to say, ideally this would be imported as builder probably. And then maybe what we call the function just build takes a builder A and gives you a module, I believe. Okay, and I'm just gonna pretend that we can always build one. It's possible that that's not the case, but we'll make do with it. We'll figure it out. So one thing we can do here is we can say, so if we were to do this, we'd have a builder here, right? This is a builder, and we could unwrap that, and inside there would be a reader-t env effect. Okay. And so we could say, well, we want to run the reader-t here. And this is going to give us now a function that takes an env, and we're going to put some initial env in there. Right. And then what is that going to give us? That's going to give us an effect. And here comes the part where you need to close your eyes real quick, because what we're going to do is with the result of that, we're going to say, well, unsafe perform effect of that, right? No, do we actually want to do that? I don't think we want to do that. Wait, let me think about that for a second. What do we want to do? We want to actually run this thing, and I think we kind of want to ignore the results of that, right? But what I actually think is that our env that the way we create one of these is actually going to be effectful. Because again, as I said, it's going to contain a bunch of references. And then afterwards, we should be able to say build module from env, and that whole thing will be unsafe perform effect. Oops, that was not what I wanted. Like so. I hope the stream is back. That was not intended. And then build module is the thing that says given an env, I'll give you a module like so. Hi Soupy, how's it going? And here is where we say empty module, like so. And initial env right now declares that it does this, but really it does this. Like so. And all this might look a little weird, but don't worry about it. It's gonna look a lot more sensible once we start adding the actual fields for env, because you might think, why do we need effects here? But the reason is that there's a bunch of references in this type. Okay, so let's get started on that, I guess. So what we'll do is we'll have a bunch of funcs, and then now comes one part where I'm always a bit split. So the idea is that as I'm using this DSL, I want to ideally be able to name functions. I don't want to have to remember indices. So, but I don't want to fix that name type to string, because there's a whole bunch of much more useful representations for variables or function names than strings when you're writing a compiler. So what I'm actually going to do is I'm going to parameterize the whole thing by a type variable. And then we'll need to pass that one through. Right. So we're going to say our envs contain names, and the user gets to choose what that type is. Just need to add an import here, data map, like so. And then we're also going to have our environment contain names here. And then all of these need to be changed, so damn it. What did I do? If I only knew my own shortcuts. Okay, so that should work. And then it says name, so a map from names to, and I'm going to call this thing func data. So let's think what data we want to collect for a function. Again, this is going to be a record. So the record is every function ends up with an index. So this is a func index. Every function ends up with a type. This is actually going to be a type index. And okay, you might be confused about why that is. Let's go back here and look at this thing. So this is the thing we end up having to build from our builder. So we need a type. The index itself is encoded in the fact that this is stored in a vector, but we don't want to store it in an array and pass around indices. Instead, we want to deal with the names that a user might be passing around. And then a function contains its locals. So locals are an array of val types. And we might decide that at some point we want to make our DSL smarter, or let the user declare these inline, but for now we're just going to roll with it. And the last thing is the body. And now the thing about the body is that it might not be there. And that is because what we want to do is we want to let the user be able to declare what a function is before they end up writing the body, because functions might be recursive, and so we need to know what to reference in our bodies, in our function bodies. And as I said, all of these will be refs because well, we need mutability here to make this nice and seamless. So I'm going to import ref here, And now this is not going to work out anymore. So this is now going to have a funcs field, like so. And funcs are empty maps when we start out, right? We start out with no maps. And so what do we need to import? This is map, like so. And this is ref, like so. And this needs to go for all name. And I'm pretty sure we're gonna have to have an OR constraint on this for now, but or in a second. But we'll do that when we get there. Okay, so here we go. So now you see why this has to be in effect. That's just because we are creating a new reference here. And now, if we had this func data, we could actually try to build a module out of this, right? So maybe let's try to start there, and then slowly add the globals and all the other stuff we want to be able to do in this builder. So, if we had an env, it would contain a funcs field, and we could read from that funcs field to get the actual funcs. So let's ref.read the funcs field. I'm almost sure, I'm going to start by just passing the empty module out here, that this is going to complain about shadowed names, which I think is a disaster, but we should really change that. Does this work? I have a feeling it's going to suck you. I do actually want to define a function with the name funcs at some point, which is going to give me a bunch of warnings. But for now, let's not do that. So now we have funcs, which is in a map of these things. And now we need to put them in the order in which the actual func index is here. Right, this func index declares in which order they need to end up in the module, in the Wasm module. And these locals are safe, and we also need to make sure that there's no body with a nothing left. So if we have a function that was declared but it didn't ever get a body, this actually needs to fail. And we could use exceptions because we're in effect for that, or we could say that this. And again, this is a program error at all times, but I think we should actually report this. So I'm just going to say build error or something is our type that we're going to be using for this. So let's declare what a build error is. And then let's say missing body. And this needs to carry a name because like so. What do you not like about build error? Build error is parameterized, that's true. But what we need to do is we need to say we need a show instance on name, or otherwise we won't be able to display this type. So let's declare an instance show build error. And we need to have a show instance for name. So show, if we have a missing body, then what we're going to do is we're going to say missing body for, we're just going to show the name. What's your thoughts about using polymorphic variants for error types? I'm a huge fan. That's basically the default I go for if I ever need to have errors that from different sources that I compare. I think polymorphic variants with error types is the gold standard. I'm not doing this here because really, if it was just me, I'd make this an exception, but I think I'm going to end up uploading this to Pursuit, and I don't like throwing exceptions from stuff that I want to be pure in the end, so I need to kind of be able to report this error to the user. If this ever happens, it means that your code generator has an array in it, so this shouldn't be a regular occurrence, but it helps for debugging, so that's why I'm doing it like this. So that's why I'm not using a variant, because I don't think people should ever have to combine this error with something else. All they want is to print this out for themselves so they know that something went wrong. And that's what we are going to do in our code generator once we get to using this module. If that makes sense. Great. You're welcome. All right, so did I not import that one yet? No. It's complaining that this is now going to be a different type, which is correct. And I'm gonna, okay, like so. Now we don't need these parentheses. What do you not like now? No show instance for name, that's right. And this is why I didn't want to do this initially, because I don't want to require the user to provide a show instance for name. Would be, but I'm gonna go with it for now. Once we have the debug type class from Harry, this might be nicer. Okay. So let's get to actually building this. And I'm gonna format this just a second here, so we can, because we might, I'm pretty sure we're gonna end up having to add more instances, because I think we need ord on name so that we can actually work with the map. Let's see. So the name, this name is only relevant for our code generator. Wasm, as you can tell from this thing, doesn't care at all. There's no name in here. There's no string. The only point where you might use something like a string is when you're declaring an export. And we might actually end up doing this from here. But for now, the func data just contains these things. So what we can actually do is we can throw away all of the names and just say map.values, right? Which is going to give us a list. Can I get an array as well, or do I need to convert back and forth? Okay, I'm going to get a list then. So this is a list of let's just go here, sorry. So this is a list of func datas, right? So let's do that. And so values, like so. And so a list of func data means that we can now sort it by the index. And then what we need to do is we need to end up deleting the index. Is there a sort function on lists, or should we turn it into an array first? I think I'm actually going to go and turn this into an array. So let's do that. So array.sort by, I believe, is the function we want eventually. But let's just say with array from foldable. Let's just start with that. And so we're going to do that on fs. And then we should have a sort by on arrays. Sort by or sort with. Oh, we're going to use sort with. And the function we need to pass here is the index, like so. And these are the sorted funcs. Right, so these are in the right order. And now what we're going to do is we're going to delete all the indices, because now they're actually part of the well, basically the array ordering is what makes the indices. And I'm not sure if there's if this just works, but I think it does. If it doesn't, we're going to do something else. But I think we could pass an s proxy here and just say delete the index field from that record. And this is starting to look a lot more lispy than I'd like, but we'll get there. Okay, so we don't have record. So let's go into our packages and actually start, sorry, Spago, start adding some of the dependencies we need, because there's a couple of them missing here. So we need ordered collections because we've been using maps. Collections like so, and we need transformers because we're using reader T. Yep, and we need record. Right? I believe it's just record. I'll see in a second. Once I go in here and say npx spargo build. Right, unknown module record, but now that we have, and I think, does Spargo have a command that lets me format the file? Just out of curiosity. Doesn't look like it. Okay, so let's just do this then. Can I just sort these lines? Ah, damn it. If I knew how Emacs worked, that would be great. Do I not have... So sort lines. Okay, and then console goes down here. Okay, that's going to make it a little easier to find stuff. You can just install this package with Spargo, which is believe we'll order them. Okay, that works as well. Okay, cool. Yeah, so we're going to... All right, that makes sense. I sorted them by hand now, but... All right. Understood. Okay. So we're going to do that the next time around. So delete now has to come from record. As proxy is imported. Okay. So I mean, this is kind of horrible, but we might clean this up a bit. So how do we clean this up? Well, really, we just... Functions. I'm experiencing a lot of buffering on the stream at the moment. It's probably due to my connection problems. I'm going to watch the recording. I only want to repeat here. Thanks for streaming the second session. Huge learning and ideas source for me. Well, for one, I'm sorry this is happening to you. But two, I'm glad you're enjoying them, and thanks for hanging out, and thanks for writing that message. People saying that stuff is definitely why I keep streaming these things. So. Thanks so much for that. So let's say those are the sorted funcs. Let's say these are the Wasm funcs essentially. Once we've deleted all of these, so like so, I believe. F's like so. And then we should be able to say empty module, and over here we overwrite funcs with Wasm funcs. Does that work? Does that type check? I think I might need another closing parentheses. Okay, it does not. So what's the problem here? So couldn't match type array with type maybe. Oh, that's because the body stuff. Oh yes, we need to do more than just this. We also need to okay, so let's keep going. So we need to do a couple things here, right? So maybe it's not just record delete. Okay, let's do a more complicated function here. It's gonna involve deleting the field, but we also need to verify that the body is actually around. So let's call this one get func body or something. I don't know. No, that's wrong. I'm kind of verifying the function here. Something like that, maybe. Let's see what we do. So what does verify func do? So verify func, I'm gonna call it wobble because I don't know what to call it yet. Takes a thing which contains all of these fields. So it contains all of these fields, right? So it takes a func data really and turns it into a, and I believe it's called func in the WebAssembly world. So let's say that. And so let's see what we have. We have a type And I believe I can't bind this because that would be silly. So we have a type, and we have locals. We should be able to bind those. And then we have a body. Right? And we have an index, but we're going to ignore that because we want to throw that one away. Now we're going to say we're going to produce a record which has a type and locals. But the body is going to be a bit different. So that's what we're going to do now. So if the body is a nothing, like here, this means that there's a missing body. But we've lost the name at this point, so that's a problem. So maybe it's not just the values. Is it value? Maybe we just need to list this thing, or to, oh, we can unfold into an array directly. Now we no longer need this part. Okay, that's cool. So what does this give us? Does this give us a tuple? It does. So we just need the index of the second thing. So tuple.second, I believe. Okay. Does that work? Let's hope this works. And so that should mean that we actually have a tuple here. So this is a tuple of name and func data. Does to unfoldable require ORD? No, it does not. That's nice. So and then we can put the name in here because we actually get that from here. Just like so. Let's just add an import for tuple. I think we have everything we need here. And in the case of a just body, and again, we need to make sure we don't shadow stuff here, which I think is kind of bad. So let's just do this then. And so you go here, like so. Now we need an import for traverse apparently. Okay, so what is Wasm funcs? Wasm funcs is now a either build error name func, right? Just build error, okay. And this is a right? Okay, seems good. So now what do you not like about this part? Let's see, do we need to declare that this is an array of tuple name func data? No, you don't. You already know that part. What's the bit you do not know? So we're traversing sorted funcs. And format things a little bit and just finish implementing this, and then we can figure it out. So what do we need to do? Well, we need to say pure map. Do you want an arrow when you traverse instead of a let? You'd think that, but I want a let here because the mod I want to be working on is effect, so I don't want the this thing to try and pick either here, right? It's all good. It's all good. So we're going to map over the Wasm funcs, which is going to map over the either part of it. And if we get Wasm funcs, so let's do, how do we do that? I'm just wondering how we're going to do that. Well, let's just do this for now, and then we can figure out if we want to make this nice or not. But so this is, in case we get a left error, we do pure left error. And in the case we get right funcs, and again, this is probably going to shadow something, which I'd ideally want this to just shadow, but it doesn't. But that's not how that works. So we can remove the pure out here. I mean, this is just a map, but I don't want to deal with the extra parenthesization here. Okay, so what do you not like about this? Record with either build error. Okay, so let's figure this one out. So this is a write like so. And we're overwriting more stuff, so wasm funcs prime or something. Really, I want shadowing to not be a warning anymore. And I mean, I know that this is a map, but I don't really want to use the infix version to make this. Well, maybe we do. So how would you do this using the infix version? So what you do is you'd say, do this, get wasm funcs prime, like so. Is that better? I don't know. I think I'm just gonna go with this for now. We can always make it more cryptic later on if we feel like it. So we don't need this import. What happened? That was not intentional. So we don't need this import anymore because we're not using record delete. So we could also drop the dependency, right, while we're at it. Just to try and only require the stuff we actually use. So we need a name for wobble. What are we doing? We're taking our func data and we're lowering it into the wasm representation, really. So I'm going to call this to wasm func. Like so. And hopefully that works. Okay, so I can already tell that this is not actually going to work because we are declaring an empty module here. Oh, well, it's going to work if you don't define a function, but we're declaring an empty module here, just overwriting the func bit. But every function needs to contain a reference to a type, which is this type thing. So really, our environment also needs to carry around types. But before we get there, we actually need a supply for the funcs we define. Because, well, we could iterate over this map every time and figure out what the highest ref we've used the last time around was, but that would mean iterating over this map a whole lot more than I'd like. So I'm not going to do that, I think. So we're actually going to use a func supply, which we'll just count up whenever we want to declare a new function. Just going to put that in there because I already know we're going to need it. So now we have types, and types here I'm actually going to say that the types are an array because I don't think in the generator we actually ever want to have names for types or something. We just need to make sure we deduplicate them. So really what this is a, what are they called? Func types? I think that's what they are. And again, we need the ref here, like so. And we're going to declare that types is a new ref, and this is an empty array, so we can just do this, like so. And we're going to need to code gen this one as well, so let's get into that. Feel free to ignore this, but I'm curious why you try to use a reader with refs over the equivalent option state without refs, or maybe mutable refs or something in ST. Is there a specific reason for picking representations if we're not picking another one? So I'll go into these one by one, but I'll start with the ST one. So you're right. Ideally, I'd not use effect on refs, but instead I'd use ST and then just not need the unsafe perform effect and instead use a run ST. That's right. I tried that, but it goes nuts. The type inference is way too annoying, and it gets in my way. So I need to make sure the interface fits. But I tried to make it an ST, but it didn't really work out. So that's why so that's that, right? Effect and ST are equivalent, just that when you do an ST, the compiler can prove that you're not leaking references, where here I need to make sure my interface is safe. The other part is I could do this in state, right? That's perfect. That's absolutely right. We could make this not refs and just use state instead, and that would be a more idiomatic API, I'd say. But I want this to all generate nice, lean JavaScript essentially. So that's why I'm doing that. This thing in effect, because the compiler knows how to turn a bunch of statements in effect into just a sequence of instructions essentially. Also, I've not used state all that much because in PureScript, because it doesn't really interact well with AF, but that probably wouldn't be a problem here. So state would be perfectly fine. This could just be state, but it doesn't really make a huge difference in terms of the amount of code I write. So I'm just gonna go with effect for now. Right. So don't take this as idiomatic PureScript. You'd probably use state thinking about it. Maybe we can write a version of this using state and then compare them in terms of performance. Yeah. So yeah, that was a good question, because I did try doing this with ST and unfortunately I failed. But someone that is better at doing type gymnastics can probably make this work. All right, cool. So types. Let's do this. So actually, I think we can just say here, give me those types, and then we can probably just cram those in there. I think. Like so. Does that work? Does not. Because we need to read them. That's true. So T's is ref.read types. And then we put those in there. Okay, that works. And we can probably break out the bit where we build the function section and we build the type section. But for now, I'm going to keep it in this single function. Okay. What else? I said we were going to do some globals. Or do we start building some functions for... No, I want to do globals. Let's do globals. Ramiska, thank you for the follow. Hope you're having a great day. So I think globals are going to carry around names, just like functions. So I'm going to put those in a map as well. And then we have a global data here, which... they're going to carry around global indices like so. And I think globals also have a type. It's just that they don't have function types. Let's check though. So globals, what do globals look like? Globals carry a global type and then init, which is an expression. So this is a global type actually. And we'll have init, which is going to be an expression. And hello, what language are you using? This is PureScript, as the stream title says, which is close enough to Haskell that, well, actually, we're using a fair amount of PureScript features, so I'd say this is PureScript. It's not just Haskell. So, and again, I could maybe this expression to allow you to fill this later if you want to do similar stuff to this. And maybe that's the right call. I'm not going to do it for now. We can, if we find out we need it later, we can put ourselves. Do we need to delay initialization of the export field? Like so, and we can figure out if we need to do that. So now globals. And here we will also have an empty map. And as with the funcs, we'll actually have a supply for these. Like so. So let's add that one over here. And here I could see us making the argument that we can just scan this because you usually don't have a huge number of globals. So it would be fine to just iterate over this map to find that one. But I think the consistency with functions here is worth it. I'm going to move the types down here because, well, there's a bit of symmetry between funcs and globals here, and the ordering doesn't actually matter because these are records, right? Okay. And if we wanted to use some cool PureScript features, we'd say, oh really, let's use ado here, if you're into that kind of stuff. Okay, so we have types and we have globals. So let's do the same thing we did here, essentially for globals. It's going to be a bit different now. So globals, we're going to read globals, which is another field on here. Okay, so it doesn't know what unfoldable we want, and that's because we haven't told it yet. So we want the sorted globals to be this. So now it knows that this has to be an array. And I think sorted globals, now we could use the here we should be able to use the record delete stuff we did before. Like so. And say, because now we don't need to unwrap the body, right? So we can just say, get rid of the index. And we want to map this over the sorted globals. Like so, we need an import for sproxy. And what's the problem here? Sorted globals are tuples. That's true. Do we care about the names? I think here we can actually go for the values, right? And just not care about this part. Do you not like this? Oh, because this now gives us two unfoldable. We can use this, doesn't matter. Oh, this gives us a map. Sorry, this gives us a list, so we need to convert it back and forth. Okay, you know what? I'm gonna go keep this one around, and then I'm actually gonna map like so. That works. Are we breaking? Yeah, we're way too large with this one, so I'm gonna move this down here. And I should probably do this instead, like so. Yeah, that's safer. Okay, now we have Wasm globals, so we should be able to put these in here. I hope so. Wasm globals. Does that work? Yeah, it does. Okay, cool. So let's try to make this a little nicer. And I actually have a bunch of extra parentheses in here that don't really unactually necessary. For example, I could delete these parentheses, but I think it's way too hard to figure out what's going on if you do that. So I don't. Okay, so now we have that. This is a bit obtuse. And I'm assuming that we could probably actually oh, let's do the trick. So npx, damn it, if I could type spago install record, like so. Okay, so it has ordered these things and formatted for us. Nice. Okay. So npx spargo build succeeds, right? Just to make sure. All right, looks good. Cool. So now we've lowered the globals and the funcs and the types. I don't want to do tables for now because I am not quite sure where we're going to do this, and data sections I haven't actually ever used myself, so I don't know about that part. I think the memory we should be able to declare though, so let's just say that that is a thing. So, and for now, I mean, so Wasm allows us to import a memory or declare one right now. In the future, is going to allow us to declare multiple ones. What I'm going to do is I'm just going to say that there's, for now, we just allow you to initialize a single memory. And this is just going to be a memory, I guess. Like so. Again, I don't know if this is the way we want to go. I'm just going to put it in there because I know that we'll want to do this eventually. So I'll put that in there. And then over here, I'll say memories, right? What do we need here? So this is an array of memory types. So let's just read the memory. Right. Does not work. We need to import it up here. Or not, import it, path and match on it. So it's in scope. And so now we can do something to memory, I hope. Turn it into an array of that. Is there a function that does that? An array from foldable, yeah, that works. There we go. And again, it doesn't like the shadowing here, which is not great, but anyway, okay. So this function is getting a little crowded. I'm gonna wait until we add one more thing before I refactor it. I think that's a good call. So this is doing 1, 2, 3, 4 things now. And as soon as you do 5 things, that's the point where you can say, okay, now I know the path and I can refactor. Okay, so now we have declared all the stuff we want to allow ourselves to declare for now. But right now, really the only interface we can have here is build and builder, and the build arrow, right? Like so. And for build arrow, we'll actually allow the user to path mesh on that. That's the only stuff we can safely expose to the user. So this takes a builder and gives you back a module potentially, or some error while building. And this is the moment in which you're going to end up building your stuff. But now it's time to actually declare the DSL, right? So this is useless. You can't create a builder right now. So now the DSL part is the thing that actually lets you construct one of these. So I'll just format this export section because we're going to start adding stuff to this. Okay, like so. So the first and most important bit is the one where we define functions. But I want to start with something a little bit simpler. So I'm going to say, let's add a function that allows us to register a type. So what do we want to do? We want to say register type. So if you give me a type, and here we want a func type, right? Yeah, because the types section contains func types. And so if you give me a func type, I'll give you, for all names, a type index for that. Okay. And so the idea here if we just check out how func types are defined, over here you can see that func types have arguments and results, and those are both just arrays of val types. And then there's eq and ord for these, so we can actually compare func types for equalities. And what we're going to do here is we're going to deduplicate function types so that we don't store more types than we need in a Wasm module, because that's a good thing to do, right? So what we're going to do is we're going to say, give me the index of this type in, and now we need to read the types we have found so far, right? So let's do that. And we need to create a builder here, which is going to contain a reader t, which is going to let us access the environment here, which is going to contain the types field, like so, right? And so what can we do now? We can read this to get at the actual types. So the types we've seen so far by reading the reference here. And then we can try to find the index of this type in there. And if we can't find it, what we're going to do is we're going to say, okay, now we need to store this type at the end of the array. So we're going to say ref.modify, and we want this one, tease. Does it take the function that modifies first? Yes. And so we want to push a new value to the end here. So we're going to, not cons, we're going to snock. And I think this takes the array first. So given that we've already read these, let's just overwrite the thing we have in there, right? So we can just snock the new type onto the t's we've already read. What do you not like about builder? This returns a unit, that's true. So this is, what's the index of this? That's the length of the types we had so far, right? Because we wrote wrote a new one to it. Yeah, I think that works. So given that if you already have an index, well, we're just going to return that one. Right, and this way we make sure we never store type twice. So this is the first function we could consider adding to our exports. I'm just going to leave it in there. I don't know if we actually end up needing it. I know that we're going to need it when we decide to let the user register funcs, which is, I think we can almost not get around it anymore. Well, we can start with register global, I guess. Is register type really a good name? A declare type, maybe? Like so. Let's do declare type. Declare global. How do we declare a global? Globals have names, right? So we're going to need a name. And this time around, because we're going to end up inserting that name into a map, we're going to need an ord instance. So we have names. What do you need to do to declare a global? I need you to give me a type and an initialization expression. So you need to give me a type, which is a global type, I believe. Right? So you give me a global type, and you give me an initialization expression, and I'm going to give you a builder of name and the global index. Right? And I might not want to let you access this global index, but maybe I need to. Wait, you need a name as well, right? That's the first thing. give me a name, a type, and an initialization expression. And then we need to return a builder, which again is going to have a reader T in there. And this thing is what lets us get at the globals. And we'll need the global supply. Right. Could you not do that to me? I want this to be over here. Okay, well, then we're just gonna do that like so. So, so what I'm gonna do, we're going to say, give me the current global supply, which is gonna be the index, the next index we're using. And so for this one, we're gonna use ref modify, which ends up giving us back the new values. So we say, let's think about this. We might end up wasting an index this way, or not having an index. It doesn't matter where we end up sorting these by index, but that could still be wrong. Let's think about this. Is there a modifier that we could use that? We could do this one, which is annoying. Let's do it by hand, whatever. I can talk about what's going on here in a second. So we're initializing this one to 0, and I want the first index I get to be 0. But the problem is that I have that if I use modify plus 1, I'm actually going to get 1 as the first index. So what I could do is I could initialize this thing with -1 up here. I'm probably going to do that. Let's just do that. Yeah, I think that's actually the best thing we can do. So we're going to modify this thing by +1, like so. And then we're going to initialize these to -1. There's no way this could ever go wrong. So I'm actually going to parenthesize these up. The parser might like this, but I don't like to have the ambiguity in there. So I'm going to do that. Okay, so what do we get? We get an index here. And then we make... What do? We push onto the globals, right? So we say ref.modify map.insert. And this is a point where I might consider throwing an exception. So if you try to declare the same global twice, that should probably explode in your face. So what I'm actually going to do is I think I'm going to throw an exception if you do that. Because that's always a mistake, but I don't want that to show up in the API, because you don't want to actually handle this mistake. If it does, you want it to blow up in your face and you want to realize that it blew in your face. So I think that's what we do. So yeah, let's do that. So let's just read the globals, I guess. So when G's map.contains, is that the map.lm maybe? Has. Do we need to do a lookup? Member. That's the function I was looking for. Why didn't it? No. So if, what's the signature? We start with a key. So if the name is already a part of G's, what do? We just throw, I believe. Read globals. Is that the right signature? Yes. So we just throw in a exception here. And we say duplicate global name. And that means we need a show here. Which again, I'm not a huge fan of, because, well, this is I think it's fine. Let's do that. So let's do this part. So what we're going to insert, we're going to insert the name. So now we're going to need to add something here. So tie and init. Type's going to be tie. Init is just going to be init. And then index is going to be index, like so. And we're going to insert that into the globals. Do you not like it? What do you not like? Right, at the end, we need to return the index. What do you not like about this one? Modify, I'm throwing away the result. Do you want to check if the global is actually the same, if map member is true? The declare type wasn't idempotent like that. That's true, but the idea with declare type is that it's perfectly normal for 2 or 3 or 10 functions in your program to have the same type. And all this does is making sure that you get the same index every time. So 10 functions having the same type just means in Wasm that they all get the same type index. But having a bunch of globals in your program that are supposedly have the same name, but maybe different types or something, is not something you should ever have. Right. So that's how you need to think about this. Sure. Oh, so we just had Rizari for us. Hello, Andika Rizari. I think I saw you in one of the PureScript meetups last time around, right? Welcome to the stream. So, hey, so what we're trying to do is we're trying to build ourselves a little DSL which lets us generate our Wasm programs nicely. And the code to do so looks kind of horrible, but hopefully at the end we can actually write pretty code on the outside. So we're going to add an export for declare global. And again, we might not actually want to hand these global indices out ever, because that's the whole point of this name thing, right? So we want to allow the user to use their own thing to reference these globals, other than ints, because that's very, very likely to go wrong. Okay, so we can declare globals. We're this close to just say, we could have start by writing out the lookup functions, but I think we need to declare funcs now. This is the tricky bit, but let's do it. So if we declare a func, there's a whole bunch of stuff that's gonna go on. That's just because functions are the most complicated and interesting part about programs in general, really. So if you want to declare a function, you need to give me a name, and you need to give me its type. So this is a func type. And then you need to give me its locals, because otherwise I can't do much. So I need the locals. How do you declare these? I think that's an array of val types. That's the locals. What else do you need to give me? Could give me a table index, but I'm not going to do that for now. Let's look at what we need. We need an index. We're going to we're the ones that actually end up deriving this one, so the user doesn't have to. You need a type and locals, and the body is empty at the point where you declare it. So I think that's all. And what I'm going to give you back, and this is the tricky bit. So I'm going to give you back a builder name. But what's the thing in here? I'm not going to give you a function index, but what I'm going to give you instead is a function that lets you fill in the definition. Okay, so I'm going to give you back a function that once you have the expression that makes up this function's body, I'm going to give you a function that you can use to fulfill. This is really a promise, to fulfill the promise that you're going to fill in the body for this function. And the important bit is that you can call this, in order to building this expression, you get to use the index we've declared. That's the interesting bit. Okay. let's talk about that in a bit more in the future somewhere. Okay, so func type. That's the step one, name, type, locals. So what is this? This is yet again a builder reader T. And whenever we build a reader T, we get access to a bunch of stuff. What did I do here? That was not intentional. So here we're gonna get access to the funcs. Do we care about the funcs? We don't, but we need the func supply, because that's the thing that's gonna give us the index. And we probably need the types, maybe not. Maybe we're actually gonna start out in the builder here. Yeah, I think we're gonna start out in builder and then we'll see what we do. So, step one, we need to declare the type that you've given us, okay? And it's very possible that this type has already been declared before, but either way, if it's not, we're gonna declare a new one. If it has been declared, we're gonna get the index of that. Either way, we're gonna end up with a type index here. All right, and then we're gonna get ourselves a new func index. And what do we do here? We did this dance to do that. I'm actually gonna say let's do next global index or something. Just gonna be a function which gives you a global index like so for all names. And all this is going to do is this is going to be a builder reader T of the pattern match global supply. And what are we going to do? We're going to do ref.modify underscore +1 the global supply. Like so. Right? And then we should be able to say in here, just do that out here. So we say next global index, like so. That works. All right, cool. And then we do the same thing, but for function is. Well, we'll see if that works or not. I think it should be. I think it ought to work. So this gives us a func index. And this is the func supply. Like so. So we're going to get our index, which is next func index. Which means we no longer need this part. So let's just ignore this for now. So what is this even going to be? I think it's going to be trickier than this, but I'm just going to go and say for now that well, this is a lie, but okay. So just to make sure that this thing type checks and I haven't made silly mistakes here. So I have. So this is global's supply, I think. What do you not like about this one? This gives back an int when it should be giving back a unit. That's right, because we don't want to throw the result of that one away. So that's how we're gonna go. All right, cool. So let's just make sure that modify actually does what it says. So modify this one. Update the value of the mutual reference by applying a function to the current value. The updated value is returned. Okay, so this is the updated one, so that's good. All right. So we declare a func. What do we do? well, step one, we need to write this thing into the funcs. So we do need this dance. So we're going to make a reader T thing. And what is it going to do? It is going to give us access to the funcs. And so what are we going to do? We're going to modify the funcs. And the function comes first. So what we're going to do, we're going to insert, and we need to do the same check, I believe. Again, you shouldn't try to declare the same function twice. That's a mistake all day of the week. So let's do that then. Ref.read funcs is fs. Like so. And then what do? We say ref.write here. Makes things a little easier. This is an f. And this is not duplicate, double declaring function like so. I think that's a better name, or that's a better error message. So double declaring global, like so. And okay, so what do we do here? We insert at the name a func data. So what do we have? We have the index, the type, which is I think the type index here. We have the body, which is nothing for now. What are we missing? We're going to write into the funcs here. And then the whole thing is now erroring because we're getting the wrong type. Locals are missing, so let's add those. Okay, so that type checks. That almost fits. I'm just gonna pretend it fits. It might fit actually, because this is got in the next line. Okay, what is this? Huh. Okay, so we declared the function, but what we need to return, that's actually the bit down here. Okay. And so what this thing does is this takes a body, or this accepts a body as an argument. And then what it's going to do is it's going to go ahead and say, I'm going to modify the funcs. Right. And now we could say, that's actually interesting. Do we do this in the same builder constructor here, or do we put it into its own thing, because that's going to read the environment again? It shouldn't matter because you can't actually change out the refs for this reader. So it should be safe to do it in here. I'm just going to pretend it is. And if we find errors with it, then we'll... You know what? I think I'm actually going to do it in certain thing. This might be a mistake. I don't know. I just feel like doing it again. So modify. I'm going to modify the funcs, and by doing this, so what we're going to do is we're going to say we're going to update add name. And now what's the function we're going to use to update? Does the function go first? The function goes first. Right. So what's the function we're going to update with? So we need to declare whether or not. So update actually lets you delete elements, but we never want to delete the element here. So we're just going to say it's always adjust. And what we do, we say, well, the body gets overwritten to be just the body you passes. That's what I think, at least. Do you not like this? And then we need a pure here. No, this is not pure at all. What is this? Oh, this is a, what does this return? This returns this, right? So a body which, like so. Yes, that's what that returns. Interesting. So the idea is that you'd use declare func, and you'd say this is the name, this is the type, and this are the locals. And then what you'd get back is a function that lets you fill in the body of the function. And what you can do, what this allows you to do is when you're constructing the body of the function, you can actually get at the index of the function itself, so you can do recursion. That's the primary thing this enables. Okay. And if you want, you can do some handling of yourself, which keeps these funcs around. We can maybe, yeah, this gives us the freedom to do things like delaying the declaration of a function till way later or something. So that's the idea anyway. So now we can declare funcs. And we actually want to allow you to do that. So declare func. So one thing we don't allow the user yet is to get at the index of a func, and you need that to kind of be able to call something. But what I'd prefer, users be able to do, I'd like them to be able to say call and then use their own name type. But that would mean that we'd have to embed this DSL into the, like build a DSL for Wasm expressions, which is one more level of DSL that I don't want to get into right now. So I'm just gonna do this for now, and if we find that this is not enough or unsatisfactory, well, then we'll figure that one out. So I'm gonna say call func, and this is gonna go and say, I'm gonna give you an inster actually. I'm gonna give you an instruction. Okay, in the builder. So what does this do? It takes a name and gives you an instruction like that. So this again is a builder reader t of funcs. And so what do? We say we read the functions. And in particular, what we do is we read, do we have a reads or something? No, we don't, okay. So we read wait, what do we get? Okay, let's just do this by hand again. And this formatting of the automatic formatting of the Emacs thingy here is really going on my nuts. Just go back. I just want you to be here. And you should close out here. So, so what we're going to do is we're going to look up a function name. Look up. And again, if this fails, this is a programming error. So we're going to say, if this happens, we're going to throw. And we're going to say undeclared function. So we also need a show instance for name. And this needs to be parenthesized up. Okay, and in case we get a func data, you probably talked about this in an earlier stream, but how are you going to deal with the lack of a GC in Wasm? Or is there one these days? Or is the goal not to actually compile PureScript to Wasm, but a different language? So, well, for one, the goal is not to compile PureScript to Wasm, but a different language. The goal is to do like a little educational thing and show how to compile something close enough to the Lambda calculus. So something with first-class functions, which is actually kind of tricky. Well, there's plenty of closure, conversion, and lambda lifting and whatnot involved. But yeah, WebAssembly as a target means that you do need to implement a garbage collector at this point in time, which is why WebAssembly is also not a good target for PureScript right now, because you're going to need to be able to implement a garbage collector that can compete with the one in V8 or WebMonkey, SpiderMonkey. So yeah, exactly. So again, really good question, and the answer is exactly for that reason. I'm not planning on compiling PureScript to WebAssembly anytime soon. Okay, so if we find an index, we're going to actually make a call instruction out of that. So we're going to make a call, and we're going to say call that index. And then we need to pure the whole thing. Let's pull this one up. So the idea is that you'd use this to construct your calls, and we're still not actually handing out the function indexes. But of course, it would be much nicer if we could embed this. And I mean, you can actually get the function index out by pattern matching on this, but hopefully you don't. But if we were to embed this into our DSL, we could make it so that the user couldn't actually ever get at the index. And the reason why that would be a good thing, or why that is why that would be a good thing, is that we could think of our own way of shifting around these indices if we ever felt like it in the future. All right, let's keep going. Do we have everything we need? I have a feeling that with this, we should be able to replace the little bit of compiling we had done before. Let's try, actually. Why not? So this is the thing we had before, where we did all this stuff by hand, right? And we didn't. Oh, we need to do the export stuff. That's true. So let's actually do that. Let's add that to a builder real quick. Let's make it its own thing for now, but it's possible that we're going to do this differently. So what is this? This is just an array of exports. Which contains an export description and a name. Okay, sure. I'm gonna do that. And then exports are empty for starters. Right. Oh, I also didn't write a thing that lets you declare memory yet, but that's fine. So let's say we want to declare an export here. We're gonna make it a little nicer than just declaring by indices again. So if you give me, we need show an ord again because we're going to look up this name. So give me a name, and I'm going to give you, actually the name it's supposed to have on the outside, right? So I need to give me an actual string, and I'm going to add an export for you. So what does this do? This is accepts a name and an outside name. So export name, I guess. So this is a builder of reader t of funcs, because we're going to end up, maybe we actually don't. Oh, we do. We need the exports here, right? So let's see what we can do here. So what we need to do? We need to call, no, we need to look up the function index, right? So we're going to end up doing this again. Actually, you know what? I'm going to do lookup func, but that's going to be an internal function. So it's going to have this type essentially. So lookup func. But it's going to give us a func index, but I'm not going to export this because I don't want users to call this. But it's going to have basically this implementation, just that it returns the index directly, like so. And then call func is just map call over lookup func of name, right? Okay, I think so. And then we can say the index is looking up the function name. And then what are we going to do? We're going to do something to the export, right? So we're going to say ref.modify. And we're going to say, these are the old exports, and we're going to array.snock and export onto that. So the exported name is the export. So what's the thing we're going to do? So name is going to be the export name. And desk is going to be an func export. Export func of the index. And then we're going to snock that, so this is actually going to go first, like so. Doesn't like that. Okay. Let's see if we can clean this up a bit. We need to declare name, like so. I think it would be quite nice to have something like maple. Yes, exactly. That's what I was thinking. So yeah, we'll definitely do that. I think that's a good idea. Making it a little nice and easy to use. So what do you not like about this part? We need to say that's actually what we're going to do. So make builder, as you said, right? So what do we want? We want a function that takes an env of name and gives us a builder name a. We want a function that takes an env of name and gives us an effect of a, right? So this is the action, and we're going to say builder of reader t action. And again, we need to I just thought the idea right there. Yeah, we should probably do that. I should probably have done that. But I find oftentimes writing down the type actually tells me the function, like lets me understand the function I want to write. So now we should be able to say make builder here, right? And that's a little nicer, I think. Like so. And this needs to be like so. So let's move this one up, because this is this goes over here, right? And then there's a bunch of places, of course, where we can now use this one instead. So this is just make builder. Right, I think that's a big improvement. Like so. Over here, this is also a make builder. Like so. And this is also a make builder. like so. But we're going to move this over here where it belongs. Do this. I need to turn off the automatic indentation thing that Emacs does because it's basically never what I want. So I just always end up moving things around more than had I just done them by hand. And we want to break things consistently, so let's do that. Oh. So. Okay, so keep going. We've got a few more of those. This is another make builder. All right. So that looks like all of them, I think. Let's look for builder constructors. That's probably going to tell us. Oh, wait, that's not going to work. Let's look for reader T constructors. So now the only place where we actually call the reader T constructor is in make builder. So that tells me that we've found all of the occurrences. So this lets you declare an export. And I think that should work. So let's say it's cool for you to declare exports as well. And I think I'm just going to get a coffee, and then we'll go and use this API and implement the code generator we had before, but hopefully a little nicer. So be right back. Ooh. Right, here I am again. All right, so as I said, we now have a tiny bit of an API. And let's see if we can make our compiler that we had, if you remember. I'm going to run it on the side here just so we get an idea of what this thing used to do. So what do we have? So Spargo run, I believe, is going to call this thing, and it's going to end up producing the result 70, and that's because we said we want to multiply 35 by 2. Exactly. So, and 35 happened to be 3 plus 4 times 5. So we made like little expression thingy here. And then the bit where things were annoying, I believe. Well, we didn't really define functions yet, right? We didn't even try. So let's try to make that a possibility now. Let's see if we can make that. Okay, so let's go. Do we need to do this at all? Do I want to go full don't want to actually let you declare functions yet. Or should we? Let's just move this over for now. It's not actually going to be a whole lot of difference because we're not using any of the capabilities we have now. We're not using globals anyway here. We're not using functions really. All we're doing is declaring a single function. But you can already tell that there's some stuff in here. So this thing declares a type that references this thing up here. And this thing references the index of this thing. And again, our DSL is kind of meant to make it so that we don't have to remember all these indices and pass them around by hand, right? Okay, so let's try that one. So compile C expression. What does this do? I think all of these things are probably fine. Let's just say, okay, let's just change this one. So test module, so compile module, so test module now is no longer us building a module by hand, right? But it's us doing something like this. Module result is equal to, and now we're going to say builder.build. And we're going to import that from Wasm builder. No, that one's not intentioned. So what does builder build do? Well, it takes a builder and turns into an either something, I think. So let's do that. So what are we going to do? We're going to declare a single function here, right? I think. So we're just going to declare a func. And the name of it is going to be main. We're going to use strings as our name type for now. Okay, we're going to declare a func name. It's going to have a func type, which is going to be a function with arguments and results. So it's not going to take any arguments. It's going to give us back a I32 though, right? What else is going to so declare func takes a name, a func type, an array of val types. So this is the locals. And I think we get those from this one, right? So what if we said that we'd actually do this in here? So locals and body, that's the result of this thing, right? Like so. And then what does this do? Okay, so this doesn't actually, what does this do? This is just the number of locals. Okay, so this is a bit of a weird return type, I guess. So when we come to declare the locals down here, we need to use this expression. You're not. Man, this indenter is gonna kill me. And then we shouldn't be needing this anymore. What's the problem here now? Well, yeah, I'm gonna put an end in at the end, and then I'm gonna say case module res of left. Well, if it's a left, we're gonna explode here. So I'm gonna say unsafe crash with error. I think we can show this probably. Like so. And then in the right case, we're gonna say this is the actual module. Right? So what do you not like about this? There's no exp. So what was is this 35 squared? I think so, probably it is. Import. Okay, this works. Okay, so let's see. What else do we need to do here? So declare func does all of these things, right? What is this even? That's a bit of a weird one, right? So what else does declare func accept? After you've given it the locals, it actually gives you back the fill function. So fill body, right? And the body, actually, we're going to fill that one. So fill body, we're going to fill that one with, really the body, like so, I think. And then one more thing we need to do after we've done that is actually we need to declare the export, right? So we need to say builder declare export, and we're going to export the function main. And let's call this one our main. So inside the program is going to be our main, but from the outside we want it to be called main. And I think this should be everything. And maybe we can use Nate's trick here. I'm not sure. I've never done this. So if I do that, does this let me just do this? No. Okay. What do you not like about this one now again? Okay, this is going to type check. Okay, so let's see if this still works. It does not, because inst export's main is not a function. Okay, so let's see why that is. So we declared an export here. So let's see if we never remember to write those out. That's the problem. So what's the exports? Isn't that just exps or something? I think it probably is. So memory exports. So all we need to do here is just say ref.read exports. And I said that I was gonna refactor this when we add one more. I just want to see if it works. And once we've done that, we're gonna refactor this. So there we go, that still works. Okay, so let's just look at this real quick and then we can go and refactor this. So why is this better, this thing over here? So the reason this is better is that there's no reference to any index in here. So all of this is tracked by us referring to our main, so some type that we get to choose ourselves that we can compare for equality really, or ordering. And so this is a lot more modular in the sense that this does not break if you shift around some indices, or if you decide that, oh no, I need to declare another function with some other name. Lovely, thank you so much. My brain's at capacity now. I'll watch the rest of the recording later on. Have a nice day. Machine Gold, thank you so much for hanging out. I'm glad you enjoyed it, and enjoy the rest of your Sunday. I think I'm going to stop at this point anyway, or I'm just going to do the refactoring of the function I said I was going to do, and then I'm going to stop, because I think this is a nice point to say we've made decent progress today. So let's see if we can pull some of these things out and make them a little nicer. So build module. So let's say we were to do different things here. So what do we want to do? We want to say build funcs. And let's write all of these functions like so. So this is not going to return a module, but instead it is going to return an array of func, I think. Let's try this one. This takes the env. Really, it takes a bunch of stuff. So funcs, types, I believe. But maybe we don't need the types with you in a second. So really all this needs to do is this, I believe. Okay, right, to Wasm func, is up here. So let's move this in here. Okay, so that works. So what we should be able to do is we should be able to say build funcs from the env. Like so. And then it should be good to just delete this stuff. And this is actually the Wasm funcs, right? So Wasm, sorry. Wait, what part is this? These are the Wasm funcs anyway. Right? Yeah, okay, that type checks. I don't think I need to write one for the types, right? Because we just read those. But the globals are a bit trickier, so let's do those as well. So build globals. It's like build funcs, but for globals. So build globals. And this is going to be an array of globals. So how do we get these? Well, we do this stuff. And then again, we say pure here. Like so, and this wants to read the globals from the env, like so. What do you not like about this part? Oh, the whole thing doesn't actually return any errors, so we can just do this. Okay. Seems good to me. So this is now build globals. So these are the Wasm globals. So given that things look like this, could we be a little smart-assy about this and use an infix operator here? This might be the one place in this file where I end up actually using an infix operator. Let's just pattern match the stuff we actually want to pattern match here. So this is type, memory, and exports. I think this works for me. How much stuff did we not end up writing into the empty module? Oh, there's a bunch of stuff. Okay, so I'm still gonna use this, do this as a record update. But if we're mapping like this anyway, I mean, we could do like nonsense like this and get rid of one more level of wrapping. Right. Do we want to do this? So what if we said these are the Wasm funcs? And then we did a map. I'm just moving some stuff around, seeing if I can make it nice, but I don't know. It's possible that we can't. And I'm not going to try for too long. Okay, this type checks. Do I like this better? I'm not convinced yet. I'm going to move this over here, I guess. Is this clearer? I don't think so. What we could do is we could turn this into a map, but that's probably just going to make things worse. Now it doesn't actually parse anymore because I did too many things here. No, that map actually goes in here. So this type checks. But I mean, this is a mess, right? Yeah, let's not do that. I think we'll just go with this. Seems good enough for me. I actually like the use of the Infix Operator here. Okay, so let's go with that for now. Let's say that's what we have. And now we have a little bit of a DSL that we can use to write our Wasm modules. So let's make a commit with that. And the next time around, we can start using this to compile more complicated programs. So that's a little builder DSL for Wasm modules. All right. I think that's going to be that for today. I think we got further than I expected. So I'm very happy with this. We might end up moving things around, but that's a good thing. I think this is good. All right, cool. So thanks for hanging out, and see you the next time around. I hope that's going to be sooner than the last time it took me to stream it.